Hello, we're starting with some word problems today. We're going through 2 out of 7.5 and 1 out of 7.2. We're just going to combine a few of those to make it a little quicker today. So this one is Kim and Yuri live in apartment buildings that are 30 meters apart as shown. The angle of depression from Kim's balcony to where Yuri's balcony meets the ground at 40 degrees. The angle of elevation from Kim's balcony to Yuri's balcony is 20 degrees. So good thing they've given us a diagram here so that you understand what that means. And what it means is if you're sitting on Kim's balcony and you're looking straight across, parallel to the ground, you've got a 40-degree angle to the bottom of Yuri's building. Now, if you're also sitting on Kim's balcony and you're looking straight across up to Yuri's balcony, you're looking at a 20-degree angle. So from parallel to the ground and up to the balcony is 20 degrees. From parallel to the ground, looking down to the edge of a building is 40 degrees. So the picture's a little bit off because it looks like the balconies are sticking out of the wall, but for our intents and purposes, we're considering that line to going straight through to the wall. So we've got some information here. First, we need to know how high is Kim's balcony. So what we're asked is, how high is that line? So what is this part of our triangle? Well, we know that is going to be the same as this. So we can do this two different ways. We can either say this straight along one is also 30 meters and deal with the 40-degree angle. Or, because we know this is a 90-degree angle, we know that this side on the inside is 50 degrees. Whether we do it, whichever way we do it, we're going to end up with the same answer, and I want you to try that in both directions. So we always start off by writing our SOHCAHTOA at the top. So let's start off with this triangle. Now I'm trying to find something that is opposite of my angle, and what I've got is an adjacent 30 meters to my angle. So if I'm looking at this one, so I know I'm going to do tangent of 40 degrees, and then I've got opposite is what I'm missing, over adjacent, which is the adjacent angle is my 30. Sorry, from equal sign. So to solve that, I need to bring that 30 over here and put this into my calculator, which gives me an opposite side of 25.17. Now, if I want to do that, same thing, using this triangle. In this case, I've got 50 degrees, and my opposite is 30, and I'm trying to find my adjacent. So tan of 50 degrees, the opposite is 30, the adjacent is missing. I've got to do 2 steps to move around this equation. So my adjacent equals 30 over tan 50, and if you put that into the calculator, you are again going to get 25.17. Now it says to the nearest meter, so we know high. So Kim's balcony is 25 meters high. B, how high is Yuri's balcony above the ground? So, to the nearest meter. So I'm going to put 25.17 in case I need to also round that. So now I need, go away. So now I need to have, know what, let's change colors again. I need to know what that length is in order to be able to add that to my 25. So right now I've got an angle, 40 degrees. I've got an adjacent side, 30 meters. I need to again find the opposite side. So tan of 20 degrees. So I'm going to use tan again because again I'm using both opposite and adjacent. Tan of 20 degrees. My adjacent is 30. And my opposite is what I'm trying to find. So again, multiply both sides by 30 to get rid of that 30 underneath. And we end up with an opposite side equaling 10.92, approximately 10.92. I'm sorry, I don't know how to shut off my things, so my announcements are going to keep popping up. So then I have to add those two together because now I've got 10.9 and 25.1 or 2 and round it to the nearest meter. So 11 plus 25 equals 36. Therefore, Yuri's balcony is 36 meters high. All right, answers out of the textbook, same as what we did. Their diagrams are a little less messy if you want to pause and look at how they've done it. Come on, change. Problem 2, solving in 3 dimensions. That's fun because now we're working in 2 different directions. A theodolite is an instrument used by a surveyor to measure horizontal and vertical angles. Measurements are taken in order to find the height of a cliff on the other side of the river as shown. So, this is interesting because people keep saying, oh, when are we going to use this in real life? This is something that actually does happen in real life. They still use this math, though they may use computers and other things as well now. But this is the math that's being used. The Mount Everest was measured by using this type of math. We could measure the roundness of the earth by this amount. My goodness. All of these things are able to happen just by using this math. You don't have to get any more complicated than this. The height of the pyramids, things like that. So what we're trying to find is the height of the cliff. So we're trying to find FC, or we can just call it H for the height of the cliff. So we've got a couple bits of information. We know that we've got these ones are going horizontally, and these ones are going vertically. So we've got 2 different angles here. We're going across the river, and then we're going straight up the cliff. So we can use we've got an angle right here that's 52 degrees. And we need to find, just as we did in the last homework, that color doesn't work very well in that picture. Just like we did to go find in our homework, we need to find the line that connects the 2 triangles. So right now, from the direction of our 52 degrees, we have one that's really close is the adjacent side because our right angle is over here, making this the hypotenuse. And we need to find our opposite side. So again, we are working in tangents. Funny about these examples are tans. So we have to find our tangent. So looking at our SOHCAHTOA, we have an adjacent, we want to find an opposite, so we know we have to use tan. Tan of any angle equals the opposite over the adjacent. So tan of 52 degrees equals the opposite over the adjacent, which is 75. Again, to rearrange, we multiply both sides by 75 and just plug that into the calculator, which gives us, we'll call that the opposite side equals, which is actually CX, equals 95.996 approximately. So let's keep it in a nice long number so that we can find the most accurate height. The more we round that number now, the less accurate our height is going to be. So now in our second triangle, the one that's going straight up, I've kind of drawn over it now. We've got an angle here that's 61 degrees. And we now know that this connecting one is 95.996. So again, we've got an adjacent side, the one closest to. We've got an opposite side, one farthest or way that we're trying to find. We know it's not the hypotenuse because that's opposite the right angle. So again, we're dealing with tan. So this time tan of 61 degrees equals, we're still trying to find our opposite. Let's call it H. So I'm not writing opposite. We're trying to find our height. Divided by our adjacent side, which is our one we just found. Again, rearranging it in the same direction. It's a shame they didn't use more variety in their answers. Equals H, which means H. Put that all into our calculator. We're getting an approximate height of 173.1. And since we said to round to the nearest meter, the height of our cliff is about 173 meters. So example 3, or example 1 again. Now I'm moving backwards to 7.2, problems we did or we skipped. So now we're not using tan, cosine, or sine. We need to recognize that we're using similar triangles and all of the various shapes that we talked about. So when we have two parallel lines and a line running through it, which ones are complementary, which ones are opposites, which ones are the same. So you need to go back to that getting ready, get ready section and remember all of those different ones. So we've got ones that are got a bunch of different ones. So the one that needs to be used now, we will get to. So to determine the width of the river, Naomi finds a willow tree and a maple tree that are directly across from each other on opposite shores. Using a third tree on the shoreline, Naomi plants 2 stakes, A and B, and measures the distance. All right, so we want to know what the distance is between the river. This is what we are eventually trying to find. Let's call it X. She's using these 3 points to make a similar triangle. So we know this line and this line are parallel. They're going the same direction. They will never meet. They will never cross. They will always be running side by side. So that gives us a lot of information. We also know this is a right angle. Because those two lines are parallel and one line's going through it, we know that is also a parallel line. That's also a right angle triangle. So what do we want to know about it? We want to find the width of the river. So we have to prove first. So step one is prove they're similar triangles. So we know, let's call this one just M and W. Angle and S. We know angle S and angle M are both right angles. Let's put 90 degrees because of them being parallel. Because lines are parallel. It's a symbol for parallel, just not well drawn. Then we know that this angle and this angle have to be the same. So angle SBA and angle WBM because they're opposite angles. So that was one of the rules that we did in that getting ready section, that if any two lines met, these two have to be the same and these two have to be the same if they're straight lines. So if we know two of them are the same, if we were to use 180 degrees minus 90 minus whatever B is, so A, therefore angle A and angle W have to be the same. Therefore, we have similar triangles. So that's step one. We have to prove that we have similar triangles. And because we have two angles that are the same, we have to have similar triangles. We know that because we have parallel lines. And we have at least one right angle. So the other one has to be right too. So now we know that if they're similar triangles, that we are sitting at the same ratio, which means that this line and this line have the same ratio because they're flipped diagrams. We know that so the ratio that we've got for 24 and 9.3 has to be the same ratio as 8.4 and X. Because we know in similar triangles, all the angles are the same, the sides have to have the same ratio. So this triangle has been flipped and turned upside down so that A is equal to W, B is equal to B, obviously, and M is equal to S. So that's flipped and turned. Or sorry, it's not really flipped, but it's kind of turned all the way around. So we know that this side and this side have to have the same ratio as this side and this side. So let's figure out what that ratio is. So the ratio is BM over BS has to have the same ratio as WM over AS. So if you understand, this is BM, this is BS. Yes, I know you believe that. This one is AS, and X, what we're trying to find, is WM. So different ways of naming the lines. So we're doing both the points are naming of the lines. So this one is a lot of notation. I don't think it's difficult as far as the math, but as far as the notation and understanding the diagram, yes, it can be tricky. So BM is 24. BS is 9.3. WM is what we're trying to find. That's our X. And AS is 8.4. So in order to solve for X, we have to divide both sides by 8.4. And then that's a matter of putting it into your calculator again. And when you do that, you're going to get an X of approximately 21.667. And since we said we wanted it to the nearest meter, we round up to 22. So therefore, the width of the river is approximately, I should put the word approximately in there, but I ran out of room, is approximately 22 meters. All right, so they've done a little neater than I have. This says angle ABS is the same as WBM because they are opposite angles. So same as what I said. Then they said angle BSA BSA, that's what I'm getting confused. Angle BSA, and BMW are both 90 degrees because they are parallel lines. So if we've got a straight line going across with B, and we knew that this one was already, that proves that this one is also a right angle. So therefore, triangle ABS and triangle WBM are similar. That's what that symbol means. So two pairs of corresponding angles we've proven are the same, therefore they're similar triangles. Step 2 is find the scale factor. So they've done this in 2 steps rather than I did it in 1 step. In ABS and triangle WBM, BS and BM are corresponding angles. Their ratio are giving the scale factor K. So basically, they found BS and BM are the same. So they found what the ratio would be for that. Each side of the triangle is 24 over 9.3 times as long as the corresponding sides to the smaller triangles, leaves the scale factor in this form for more accurate. So we could figure out what that means, but we're going to leave it there for more accuracy. And then they took that and put it in. So I just did it all in 1 step. Down here, they did it in 2 steps. That's it. Key factors. Angles of elevation and depression are measured above and below the horizontal line. So basically some definitions for you. You have a horizontal line, an angle of elevation, goes above that line. Angle of depression goes below that line. The primary trigonometric ratios can be applied to solving two-dimensional and three-dimensional problems. And some complex problems involve working more than one right-angled triangle. So you're starting to get that we need more than one. Homework. Yay.